Sage again. There's many ways to do it. What some people do is just leave Sage open all the time, right? What I'm going to encourage, though, is that you learn how to launch it in several different ways. One is to go to the Finder, New Window, Applications. Within the applications, just double-click on Sage, and then launch it from the terminal, right? It's already running for me, so I'm not going to do that. All right, let me close it out. The other way to do it is go directly to the terminal, and I'm going to do a new window, and use the up arrow. And the up arrow is going to eventually go back to a command, unless you use the terminal a lot. The command's going to come up pretty quickly, where you see it says Sage, Applications, Sage Math, 9.4 App Contents Framework, Sage Framework. I don't want to memorize that, but you realize it would launch Sage for me. All right, let me close that window. And I got Sage running. All right, what are we going to do over here? Standard functions and constants. All right, so max is a function. What does it do? It gives me the maximum of a list of numbers. All right, fairly straightforward. Right, minimum, fairly straightforward. Maximum, fairly straightforward. ABS stands for absolute value. Right, fairly straightforward. Fairly straightforward, absolute value of an arithmetic problem. Floor, a little confusing for students. And what I mean by that, it's something that's introduced in calculus or also in computer science. And again, it's a defined function. It's also called the greatest integer function. Now the floor, whoops, let's say minus 1.1. Whoops, minus 2. I get a feel for this. You think about the output as you're doing things, and you really do. You want to think about the output as you're doing things. Ceiling. All right, let's do ceiling of 3.6. Well, if there's a floor, there's a ceiling. That should be 4. And ceiling of minus 1.1. And again, get a feel for the not only the command, but the output of the command. Right? Think about it. Right? Think about these things. Let's take a look at this one over here. And it says clearly not correct. What happened? Well, you may want to read through that. Something happened over here about the impreciseness of this approximate arithmetic. All right? But again, read through that. Don't be confused sometimes with computers. They can be really kind of crazy sometimes when they answer questions if you don't know how to use it properly. All right, so I'm going to keep going and just looking through this over here. Square root function, SQRT, 15. Well, I can't do it. Now, certainly, they do talk about other ways to write this stuff down, using that dot notation or the Python type notation. But most people want to do it in square root of 15 and want an approximate to it. And one way to do that is just put a decimal point somewhere. Another way to do it is don't put the decimal point down, but use the dot n notation. All right, you get the idea. There's many ways to get an answer over here. All right. Not too bad. Just basically, doing arithmetic with fractional exponents. Doesn't look too bad. Sine function, sine of 1. Now you're in radian mode, so not going to give me the answer to it. Even if it's a degree mode, it wouldn't give me the answer either. Put a decimal in, you get an approximate answer. I think you get the idea. Pi is a constant. If you want to approximate pi. All right. And again, just going through, looking over here. Nothing too spectacular at this point. I do want to point out that if I type in sine of pi, it's 0. But if I put in sine, and this has to do with that approximate arithmetic, by the way, quite dangerous. What's going to happen now is that Sage is going to actually compute pi to a certain number of digits. And then the sign of that is really not the sign of pi, it's the sign of an approximation of pi. So it'll be approximately equal to 0. And that number is approximately equal to 0, but it's not 0. But again, sine of pi is exactly 0. So be careful between the difference between exact arithmetic and approximate arithmetic. That's often confusing, and sometimes if you don't even know what happened, and you get confusing results, I'd look at what you're coding to get through that. Arctangent, let's do arctan of 1. What do you get, a quarter pi? If you get arctan of 1.0, you get an approximation of a quarter of a pi. By the way, I want to point out that a lot of times when students are looking at that 1/4 star pi, they think it's 1 divided by 4 times pi. That is not the case. It's pi divided by 4, all right? That's another thing about output. You got to be careful. Make sure you understand what you're doing before you type things in, by the way. E is Euler's number, all right? E dot n will approximate Euler's number, yada, yada, yada. Ln is natural log. That should give me one. I want to point out that log in Sage is base A. All right? All right? Now, if you want to do a different log base, you'd have to tell them what the base is. For example, if I do log 10, let's do 10.0, that's actually, if I took the number E and raised it to that power, I'm going to use an underscore. An underscore is the prior result, and that should give me back 10, and it does. Now, if I want log 10 base 10, that would be 1. And why is that 10 to the first power is 1? Let's do log 8 base 2. And we get 3 as expected. All right? 2 cubed is 8. All right? EXP stands for E. Put this down over here. I'm going to do something I haven't seen before. Boolean. I'm going to type EXP 1 double equal sign. We'll get to this more later. Does that equal the number E? It says it's true. All right. You get the idea of some code over here. Not a number. Golden ratio. Log 2. Euler gamma. Catalan. Khinchin. Twin prime. Mertens. Just some constants that are built in. Exercises. See if you can get through them. Again, I provide answers for you. Thank you.